This video will be on section 2.5 on the derivatives of composite functions. Because this section involves combination of derivative rules, I've separated this section into two videos. This video is the second video, which I will be only solving complicated problems and different types of problems you might encounter. So if you're not familiar with this section or looking for a video to learn, we have the part 1 of this video, which you can access through our channel. The first question is asking differentiating each function, which is I only put 1. Do not expand any expression before differentiating. So I see that this is, I can apply the quotient rule if I want to take the derivative. So remember, the quotient rule stated that if you want to take the derivative of fx, you do it by taking the derivative of fx and then keep gx the same, minus keep fx the same, take the derivative of gx then, all over gx squared. So if I apply that, I see that my fx is actually here. This is my fx. And here would be my gx, right? And over here, if I apply that, taking the derivative of fx would just give me a constant. Taking the derivative would give me a 0 because it's a constant. And here would be 0. And if here is 0 and gx is times by 0, it's just 0. So everything cancels out. So I'm going to put the minus sign and keep fx the same, which is 1, right? And take the derivative of gx. My gx is in the form of x squared minus 16 to the power of 5. I can take this 5, put it to front, right? Because here is a function and not just a number, we keep it the same. Take 1 out of the power, so 5 minus 1 would just give me 4. And then I multiply it by the derivative of gx. So since my gx is right over here, taking the derivative of this would just give me 2x by the power rule over here. So I take the 2, put it into the front, and do minus 1, you'll get 2x. Since negative 16 is a constant, it will just give me a 0, so that's my answer for the numerator. All over, take the gx and square it. So right now I already have x squared minus 16 to the power of 5. On top of that, I'm just going to square this. Now if I multiply 5 by 2x, I'm going to get 10x, and then I'm going to multiply it by negative, so that would give me negative 10x. And then I'll just put this gx to the power of 4 as it is. So x squared minus 16 to the power of 4 all over. When you have something like this, you do 5 multiplied by 2 and put it as power. So I'm going to have x squared minus 16 to the power of 10. I see that I can actually cancel these out by dividing each of them by x squared minus 16 to the power of 4. If I do that, I'm going to have 6 left over here. So my answer is going to be negative 10x all over x squared minus 16 to the power of 6. So this question is saying rewriting each of the following in the form of y equals u to the power of n, or y equals any constant and then u to the power of n, and then differentiate. So when you have something like this before, in the previous one we just used quotient rule directly, but now it wants me to, before using anything differentiating, it wants me to write it in these forms. So to do that, we actually did that in like previous videos. I can actually say y equals 3 and then put 9 minus x squared as power of negative 1. So it means the same thing. So it comes to this format because I can count 3 as my constant. My u would be over here, this equation, and then my n value would be negative 1. So if I differentiate from here, I can actually apply the power rule and constant multiple rule because I have the constant right over here. I'm going to keep the 3, my constant, as it is. My n value is negative 1. I'm going to put that to the front. So now I have negative 1 in the front. I'm going to keep my u the same because it's not just a number, it's a gx. Remember, we keep the gx the same. And then I do -1 to the n, which would give me -2. Now I take the derivative of the inside. So that would give me, for constant, it would give me 0. And then if I take the derivative of this by applying the power rule, it's going to give me negative. You keep the negative because this negative over here counts like a constant. So -1 is there. And then we're going to put 2 to the front, keep x the same, and do -1 to the 2, which would give me just 1. And I'm going to write that as -2x. Now from here I can actually get -3, 9 minus x squared to the power of -2, and then -2x. I'm going to multiply these two together to get 6x all over 9 minus x squared to the power of 2. I put this part in the denominator because it has a negative. So whenever you have a negative in the power, it just goes to the denominator. So that will be your answer. In this question, I see that I have a table of values. I see that they gave what h is, where f and g are continuous functions, and we need to use the information from the table to evaluate what h -1 is and what h of the derivative of h -1 is. So I see that it's a composite function, and I see that I can also rewrite this as g fx. So remember the composite functions, the previous video. So for those, I see that since this h equals to that, I can actually find whatever the fx is inside, plug that back into the g, and then find what my h is. So since I only have values over here and not what my fx is, not my gx is, what I can do is plug in -1 to find my h. So in order to find h -1, we would plug in -1 to the x. So that would give me g f -1. So now all I need to do is find what is my f -1. I see that when x is -1, my f is going to be 1. So the whole thing just turns out to be 1. So it's going to be g1. So now I need to go ahead and look what 1 is, because my x value is now 1, right? I look at what 1 is, and then now I look at what gx is when I plug in 1 to my x, which is -4. So my h -1 value is going to be -4. Now for the second part, I see that in order to take the derivative and the same x value, -1, I know my composite function looks like this. But when I'm taking the derivative of the composite function, it's not simply the derivative of like g and f. Remember that when you're taking a derivative of a function like this, you take the derivative of the outside variable first, keep inside the same, and then multiply by the derivative over here of the inside. So if we do that, what we're going to get is, first I'm going to start with whatever is inside over here. So I'm going to plug in -1 for my x value. So I see that if I plug in -1 for f, so my x value is -1, I look at fx, not the f prime x, fx, which is 1. So I will get g prime 1 multiplied by, and I see that when my x value is -1 again, but I plug it to the derivative of fx over here, I will get the value of -5. So my value is -5 over here. Now all I need to do is look at the x value of 1 for g prime. So I look at the variable 1, and then I go to g prime, which is -7. So my value is -7 times -5, which will give me 35. So that's my answer. Find the rate of change of each function at the given value of t. Leave your answers as rational numbers or in terms of roots and the number of pi. So the function given to me is here. and it wants me to plug in 2 pi where t is. First, we need to actually take the derivative of this, which we apply 2 different derivative rules. First one is the power rule, where I bring the 1/3 to the front, keep gx, which is right over here, the same, and then take the derivative of gx. When I'm taking the derivative of gx, what I do is I apply the quotient rule to find that derivative. So the first thing that I'm going to do, like I said, is bring 1/3 to the front, keep gx, which is right over here, the same. So I have t minus pi all over t minus 6 pi, do -1 to the power, which I can do 3/3 means 1 anyways, which will give me -2/3. So my power is -2/3. Now I apply the quotient rule to find the derivative of the inside. When I do that, remember how the quotient rule is. I take the derivative of fx first and then keep gx the same minus fx, and then take the derivative of gx, and then take the denominator, which is gx, and square it. So if we do that, what I'm going to get is taking the derivative of fx, which is up here. This is my fx. Taking the derivative, this is t to the power of 1, which will just give me 1. And pi is a constant, so anything constant when you're taking the derivative is just 0. So I took the derivative of fx. Now I move on to gx, which is right over here, and I just write it as it is, which is t minus 6 pi minus, then I take the fx, write it as it is, which is t minus pi. Then I take the derivative of gx, which is right over here, which comes to the same thing as the derivative of fx. It just comes to 1. Because 6 pi is a constant, it just becomes 0. T to the power of 1 is just 1. All over. And then I square my gx, which is t minus 6 pi, and then square it. So now I'm going to go ahead and simplify it. I wrote 1/3 as it is. I'm not going to touch it for now. Because I have negative, whenever we saw a negative, we just took the reciprocal of it. We just flipped it. Same thing over here. Whenever you see a negative, but you have functions for both the numerator and denominator, just flip it. It comes to the same thing. So t minus 6 pi, I'm going to put it on top instead of the bottom. And I'm going to put t minus pi to my bottom. And my 2/3 is still there. I just got rid of the negative sign. Now I'm going to go ahead and simplify here. So I see that I have t, which is positive, and I have, if I distribute the negative sign, I have a negative t, which I can cancel them out. I have -6 pi, and if I distribute negative to my negative, I'm going to get positive pi all over t minus 6 pi squared. I see that if I add these two up, I'm going to end up with -5 pi. So I'm just going to go ahead and do that. 1/3. And for here, I'm just going to distribute what 2/3 means. You don't really need to do it, but I'm going to do it just for visualization. So what this means is actually squaring whatever you have and then taking the root, but cube root, because you have 3 in the bottom. So whatever is in the bottom goes for the root, whatever is on the top goes for the square. And same thing for the bottom. So I have t minus pi square and then cube root. For here I said I'm going to put -5 pi, and I'm going to keep the bottom same for now. Now that I have everything, to make it easier, I can go ahead and actually plug in 2 pi, whatever is given, for my t's. So when I plug in 2 pi, what I'm going to get for the first portion, I wrote 1/3 down. And for the first portion, 2 pi minus 6 pi will give me -4 pi. And squaring that would give me 16 pi squared over Same thing, 2 pi minus pi for the bottom right over here will give me pi, and it's just going to give me pi squared. Done with here. For negative 5 pi, I'm just going to write it as it is. We don't need to simplify anything. And here, 2 pi minus 6 pi is the same thing as we did for the bottom, which is going to give me negative 4 pi. And squaring that would give me 16 pi squared. So I'm going to continue up here. First, what I'm going to do is actually put these ones together, meaning I'm just going to multiply the bottom 16 by 3. So that would just give me negative 5 pi over 48 pi squared. Yeah, and then that's it for that. And for this portion, what I'm going to do is I'm going to separate 16 and pi squared, and you'll see why. So if I separate, this is 3, oh, let me do that again. Root, cube root, and I'm going to put 16. And when you do times cube root pi squared, it means the same thing. And I have cube root pi squared over here too. And yeah, that's it. Now I see by separating them, I can actually cancel these two. So to get rid of it, it will be easier for me. And here I see that I have 16, but this I can actually rewrite it as having 8 times 2 and the same root inside of the same root. And I see that I can actually take out the cube root of 8, because cube root of 16 I can't take it out perfectly, but for this I can actually take out 2 and keep this 2 inside, so I have cube root 2. So I'm going to do that for the top. Right now I have negative 5 pi, and for the bottom I'm going to put here this one, so I have 2 and then cube root 2 all over 48 pi squared. And now I see I can actually multiply 2 by 5, which will give me negative 10 pi, and then cube root 2 all over 48 pi squared. Now I can actually go ahead and cancel this pi, divide each side by pi, which will only divide 1 pi over here, so I still have that pi left. And I'm also going to divide both sides by 2 because it's divisible. So if I divide this by 2, I'm going to get 24. And if I divide this by 2, I'm going to get 5. So my answer is going to be negative 5 cube root 2 all over 24 pi. And that's going to be my answer. So make sure for these problems that each step you're doing, you're making sure that they're correct and there are no errors, because just a small error or something in the middle can actually lead on to a wrong answer. So for what values of x do the curves of this function and this function have the same slope? So because it says the curves, I can see that I'm applying derivatives over here. And when it says the same slope, I know when I take the derivative of this and when I take the derivative of this, it will be the same number. So technically, me taking the derivative of this and this, I can just equal them to each other. When I do that, I'm going to start by taking the derivative of, let me erase it all. I'm going to start with taking the derivative of this first. So I will be applying the power rule first. But remember here is inside is gx. So I'm going to say, I'm going to bring the 2 to the front. So that's going to be 2, keep gx, which is inside the same, so 1 plus x cubed. And when you do minus 1 to the power is just 1, you don't have to write it. Now you take the derivative of the inside. I know the constant is just going to be 0. Over here I'm going to apply the power rule, bring 3 to the front, x, and do minus 1 to the 3, which will give you 2. So now I'm going to equal this to taking the derivative of here. Now you know this is the constant multiple rule where you take the constant, it's going to stay here. Now you apply the power rule to the x to the power of 6, bring 6 to the front, keep x the same, and do minus 1 to the 6, which will give you 5. Now you can simplify it further. I'm going to multiply these two together first, which will give me 6x to the power of 2, and then I have in brackets 1 plus x cubed equals 2. Now I'm going to multiply these two together, which will give me 12x to the power of 5. I'm going to distribute 6x squared into the brackets, which will give me 6x squared plus 6x5. Whenever you multiply x cubed or like with x squared, you just add the powers, which will equal to 12x to the power of 5. Now I know I can take this, put this to the other side as negative, and remember, since both of them are x to the power of 5, I can just do minus immediately. So now I have 6x squared will equal to 12 minus 6, which is going to give me 6x to the power of 5. I'm going to also send this to the other side as negative to equal to 0, which will give me 6x to the power of 5 minus 6x squared. I see that I can actually take out 6x squared out of here. So when I do that, I'm going to end up with x cubed minus 1. Now from here, because they both equal to 0, I can actually say for here, I'm going to put it up here, 6x squared will equal to 0. Divide by 6, you're going to get x squared equals to 0. Now take the root of each, x equals to 0. So one of my answers is x equals to 0. That's my value of x, where these slopes will be equal to each other. The second portion is here, which I will be equaling to 0 as well. So x cubed minus 1 will equal to 0. X cubed, send negative 1 to the other side as positive, so positive 1. Take the cube root of each side to get rid of that cube. So my x is going to be equal to 1 anyway. So whenever you take the root of 1, it's just 1. So that's my other answer. So I can say for values of x equals 0 and x equals 1, the slopes of these two functions are equal to each other. So for this one, it wants me to find the derivative of h when my x is 2 and my hx function is given by here. So it's a composite function. And I have what my fu is here. I know what my f function is, but I don't know my g. But they gave me what g is when x equals to 2, when it's plugged in, and it gave me the derivative of g as well. So I'm going to start by taking, because this is not in the derivative form, I'm going to start by taking the derivative of hx first. So when you take the derivative of hx, we did this before, we take the derivative of outside first, so it would be f prime, keep gx because it's inside, keep gx the same, and then multiply it by the derivative of the inside, which will be g prime x. Now I have everything that I need to work with. I'm going to go ahead and plug in 2 for my x, which will give me f prime g2 multiplied by g prime 2. Here I see my g2 is already given here, which is a value of 3. So I'm just going to say 3 over here because my answer is already here. Multiplied by g prime 2, which the answer is already given as negative 1. So I write that as well. Now for f prime, I see that this is not a prime, this is only like fu, which I can actually put in 3 by taking the derivative of that function. So when I'm taking the derivative of fu, that would equal to, use the power rule over here, bring 2 to the front, keep u the same, and when you do minus 1 to the power, it's just going to become 1. And negative 1 over here, because it's a constant, it's a 0, so I have 2u. Now I'm going to go ahead and plug in 3 over here into u, which will give me what f prime 3 is, and that would equal 2 times 3 as 6. So I have 6 times negative 1, which my answer is going to be negative 6.